This is presentation of the HCI final project, evaluating the user experience of information visualization to design better crowdsourcing visualizations for non-expert. With the fast development of internet and technologies of social media, information and data become more important and closer to people life. The scale of the information and data is doomed to getting larger. It could benefit people, but if not properly dealt with, information overload might result in loss of information and people's resistance. Information visualization is a good solution to this case. Through graph, chart, and maps, it might help users to communicate with data and information more efficient and more effective. Information visualization is also widely used in persuading and decision-making situations. Thus, the idea of this study is to find a way of designing better information visualization for non-expert and benefit more people. The study mainly covers 3 parts. The first part is controlled lab user study, which collects qualitative data through usability tests and interviews. The second part is analysis of data, which applies qualitative and quantitative research to find the pain point of experience. The third part is design better user experience for non-expert according to the findings. The idea of design crowdsourcing information visualization can help to further understand users. For the lab-controlled study, there are 6 participants in group of expert and non-expert. There are 1 guideline and 3 visualization tasks in their user tests. After viewing these charts, users are asked to describe their feeling and discovery of the visualization. The dataset used in this test is iris species data. It includes attributes of the length and width of the petal and sepal, and 1 labels with 3 values of species. The information of the dataset tells participants about what kind of problem they are dealing with. The first task is a bar chart. It represents the average length and width of sample flowers, petal, and sepal by bars. Users can also make comparison between different species and interact with the different colors of tags to exclude or restore dimensions in charts and bars in tooltips to know the value of bars. The second task is a scatter plot. Participants can observe the distribution of different species in dimensions of 2 attributes. They can also click tags or plots to further observe clusters and points. The third task is a box split, which uses separated distribution of 3 species, where box indicates the range and average value of plots. It provides more specific view of each sample species. After collecting all the user data, we used an analytics standard of information visualization to evaluate their performance of the testing. High-level performance is that when they can recognize the meaningful classification, correlations, and patterns of data, while low-level performance is correctly allocating the target value in points or making some useful comparisons. The standard is used to give scores to participants and contribute quantitative analysis. You can actually find out that expert group performed better than non-expert. Through method of think aloud and observing users' behavior, it addresses users' pain point according to usability goals of effectiveness, efficiency, easy of learn, and engagement. There are 3 representative findings for non-expert experience: do not understand the use of charts, failed to interact with charts, and too much information. With respect to these findings, there are 3 main solutions. The first one is to involve less information and dimensions in each view, which is actually the idea of keeping the design simple and clear no matter there are how many contents. The second one is to utilize animation, graph, and color to make the underlying patterns intuitive. For an example, when non-expert sees 2 elements in the same view change at the same time, they tend to imagine that these 2 elements are correlated. Such design may also attract users to explore more and have better engagements. The third one is to involve real-world meanings in the design, which inspired by the results that participants who connect dataset to real-world cases often perform better. Lastly, the study introduces a design of crowdsourcing visualization. Since crowdsourcing can easily access more people, it can help to analyze large quantity of data in certain format, which helps designers to know more about preference of most people, that is, non-expert. It can also play a complementary role for lab-controlled study in the user research. The design includes 3 different types of charts that enable users to make selections: real images, bar chart, and scatter plot. Users of the crowdsourcing can select dimensions, types of charts to customize the visualization, and then made their decision of given data points. It is like a design of creating persona for the crowd in dimensions of types of charts, dimensions of visualization, and the submit decisions. It could help designers to utilize the wisdom of the crowd to design better information visualization for non-expert. That's all of this presentation. Hope you enjoy it.